we have discussed about gradient. Now I'll come to two more operators in space domain, that is divergence and curl. See, we discussed gradient as gradient of f as say gradient of phi. We discussed gradient of a scalar. Gradient defined for the scalar function. We defined it as, this was an operator, del phi was defined as I del by del x, dou by dou x phi. Similarly, I define divergence of any vector function. Divergence of the function, say f, a vector function f, which is written as div f, or I can write it as del dot f. It is defined as, see, the definition is sigma I dot f vector. This is x, all right. Similarly, the curl of any function f, written as curl f, we write it as curl f. It is given by this, and we can write this as sigma I cross dou by dou x f. All right, so we can write like this. We can write like this. All right, divergence and curl is defined like this. I repeat it once again. Your del phi is sigma I d by dx phi. Here del dot f is sigma I dot f, and curl of f is sigma I cross del by del x f. This is how we define. This is how we define these operators. Divergence and curl is defined like this. Now, what is the meaning of divergence? What is the significance of divergence? I will discuss a bit on this. What is the significance of divergence or curl? All right. See, the significance of divergence. See, we talk about significance when we use this divergence in basic sciences. See, usually in basic sciences, see, in mathematics you can define divergence of any function, but divergence of any function is significant. It has got a physical sense only when that function denotes some kind of flow quantity. See, divergence of f, I can define in mathematics divergence of any function, but divergence of function is physically meaningful only when that particular function denotes some flow quantity or something, some quantity which is analogous to flow quantity. Like, say, in fluid mechanics, we have a flow quantity denoted by the fluid velocity. We have a fluid velocity. Fluid velocity is defined by q. So if I define del dot q, what does del dot q denotes? Del dot q denotes either source or sink of fluid. Means if at any point del dot q is positive, it means at that point there is a source of fluid. If at any point del dot q is negative, means at that point there is a sink of fluid. Like if you have certain point from where the fluid is flowing out, like this. Suppose you have the fluid coming out from certain point, then it means at this particular point your del dot q, this fluid velocity denoted by q. So at this particular point del dot q is positive. It means at this point del dot q is positive, means here you have the source of fluid. Similarly, if at some point you have fluid going in, right? At some point you have fluid going into this, at this point. So at this point it means you have a sink of fluid. Here del dot q is negative at this particular point. Here your del dot q is positive. So del dot q, the divergence of any vector field is significant only when that field denotes some kind of flow quantity or something analogous to flow quantity. Similarly, if I have, say, electrostatic field like this, if I have a electrostatic field like this, right, this is the electric field. though electric field is not a flow quantity, but it can be seen analogous to flow quantity. So if you have this kind of field emerging from certain point, it means I can conclude that at this point you have some kind of source of electrostatic field. It means you have some kind of charge. You have a del dot E is positive over here. So del dot E is positive over here, right? So I have a presence of a positive charge over here, whereas if you have something like this, the field going in, it means you have certain negative charge over here, because you have a sink of electric field. Del dot E is less than 0. So you have a negative charge because you have del dot E is given by rho by epsilon naught, right? So this is the significance of divergence. This is the significance of divergence. Now I'll move on to the curl. What is the significance of curl? See, the curl is also defined for some kind of flow quantity. We are now going to define the significance of curl. What is the significance of curl? If I take the same fluid, see, sometimes the fluid is coming like this. Fluid is coming like this. You have the fluid coming like this only, right? In this case, you see the fluid does not have any rotational sense. Fluid does not have. Curl denotes the rotational. Curl gives you, curl of any vector function gives you the rotational feature of that particular field. See the fluid is coming out like this. Here I can conclude that your del cross Q is 0, right? Your del dot Q is positive. Sometimes if you rotate a fluid in your bucket, the fluid goes like this. Fluid goes like this. All right. The fluid revolve like this. So here you don't have any source of sink. See, you don't have fluid coming out or going into some point. You don't have fluid going out or coming out or going into some certain point. So you don't have a source of sink. Otherwise, the fluid would have moved into or fluid would have come from this point. So you don't have a divergence. Your divergence is 0. You don't have any source of sink over here, but you do have a rotational sense. So you say del cross Q is non-zero. Sometimes you have both, like you have in your bucket you have certain holes, so the fluid goes like this, fluid goes like this, right? So what do you have here? Here you have rotational sense as well as fluid is going into it. Here you have divergence also getting non-zero, and your curl is also non-zero. It has got certain rotational sense also. It has got some rotational sense also. So you have curl also getting non-zero and your divergence also getting non-zero. So this is how we can understand the significance of divergence and curl, right? So I'll move on to the properties of, you have some identities, vector identities. I'll list down those vector identities and then I'll move on to the problems.